Hello everyone. Today in this video we are going to talk about the relationship between magnet and the current. So after this video you should be able to explain the magnetic effect of electric current and draw the magnetic field of a straight conductor. Suppose I have a magnetic compass. I want to deflect this compass without touching it. So to do that I can bring a big magnet near to it. So when you take away the magnet, it will come back to the same position. So to deflect a magnet, we need another magnet. Now let's talk about the Oersted experiment. He took one magnetic compass and he placed it near a conductor and he connected the conductor with the circuit. And when he switched on the circuit, there was a deflection in the magnetic compass. When he turned off the circuit, the magnetic compass came back to the same position, and when he changed the direction of the current, the direction of the deflection also changed. So now from our previous slide we know that in order to move a magnetic compass we need another magnet. So but out here in the experiment there was no magnet, so he gave the conclusion that a current carrying conductor produces magnetic field, due to which a magnetic compass shows deflection. So due to this conclusion we got the new chapter, that is magnetic effect of electric current. The magnetic effect of electric current means when current flows through a conductor, a magnetic field is produced around the conductor, and this effect is called magnetic effect. So we have seen that whenever there was current, there was a deflection in the magnetic compass, which means that current carrying conductor produces magnetic field, and this effect is called magnetic effect of electric current. Now when I say magnetic field around a conductor, we should draw the magnetic field and we should give the direction of magnetic field as we have done in the bar magnet. Now let's draw and find the direction. So before that, this is the activity to prove the magnetic effect of electric current. So this is the same experiment we have done in the beginning. We'll see the pattern of magnetic field of a straight conductor. So for that we take a straight conductor and we pass it through a cardboard and we connect it to a cell. Now we'll sprinkle some iron dust on the cardboard and we'll just give a gentle tap on the board, then we'll get the magnetic field. So this is the pattern. So we can see these are the circles around the conductor. So this is the activity that we have done. So we can do one more activity to trace the magnetic field. So same thing, we have a cardboard through which a conductor is passing and we are connecting the conductor to the cell. Now you have to keep one magnetic compass, so it will show a deflection, then we'll put two dots, then we'll put next compass, it will show the deflection, then we'll put one dot, then another compass, one more compass. So we keep on putting the compass around the conductor, then we'll finally reach the same position. Then we'll join all the dots, then we'll get a circle. So similarly we can put compass in other position as well, so we'll get other circles. So this is a magnetic field of a straight conductor. So this is a real picture. You can see all the compasses are showing the direction of magnetic field. So when you join them, you will get a circle. So this is a magnetic field of a straight conductor. These are concentric circle. Concentric circle means one circle over another circle. So this is the magnetic field from another angle. So you can see concentric circles. So but we not only get one magnetic field, we get the magnetic field in every position of the conductor. So out here, so these are all the magnetic fields of a straight conductor. But while drawing, we draw only one portion, but there are magnetic fields in each and every point of the conductor. So we have got the pattern of magnetic field. Now we need to find the direction of magnetic field. So now let's find the direction of magnetic field. So before we find the direction of magnetic field, I want you to hit this button, because we'll get the direction of magnetic field using this button. And the name of the rule we use is called right hand thumb rule. So let's talk about right hand thumb rule. So it says that when we hold a conductor in our right hand in such a way that the thumb shows the direction of current, then the curling of four fingers shows the direction of magnetic field. So out here in the figure, so current is going towards the left and I'm holding the conductor. So we already know the magnetic field lines are circles, so we need to give the direction. Now as you can see, the curling is going in this direction, so I have to put the arrows in this direction. So one more diagram. So out here the current is going in upward direction, so I'm holding the conductor in such a way that thumb shows the direction of current, then the curling of four fingers shows the direction of magnetic field. So out here you can see the magnetic fields are going towards the right. So out here also the current is going upward, so if you hold the conductor with the right hand, then the curling of four fingers shows the direction of magnetic field. So from above the conductor, magnetic fields are going towards the right, and from behind the conductor, the magnetic fields are going towards the left. So if the current is going in downward direction, then again I'll hold the conductor with right hand, thumb pointing the current, then you can see from above the conductor the magnetic field is going towards the left, and from below the conductor magnetic field is going towards the right. So this is the statement and this diagram. You don't need to draw all those diagrams, only one diagram will do the job. So this is right hand thumb rule, and the use of right hand thumb rule is to find the direction of magnetic field of a straight conductor. Suppose this is a conductor and the current is going in upward direction, so I have to draw the magnetic field of this conductor. So we already know the magnetic field lines are circles, so I'll just draw one circle, but I'll draw this circle in such a way that the part which is above the conductor is solid and the part which is going below the conductor is dotted. So in order to draw the direction, I'll use right hand thumb rule. To use the right hand thumb rule, I'll hold the pencil in such a way that the pointed part of the pencil shows the direction of current. Now when you hold this, so you'll see that your curling of forefinger will go towards the right from above the conductor. So out here you can see from above the conductor your fingers are going towards the right, so that means you have to give the direction in this point and the direction is going towards the right. While drawing the circle, don't draw the circle like this, you have to make it this way. So next, suppose the current is going in downward direction, so I have to draw the magnetic. So we know magnetic field lines are concentric circles, so I'll just draw one circle. The part of the circle which is going from above the conductor is solid and the dotted part is going from behind the conductor. So now again I'll hold the pencil in such a way that the pointed part of the pencil shows the direction of the current. So now the curling of forefinger will go towards the left this time, so I'll give the arrow towards the left. So this is the magnetic field of this conductor. Let's find the direction of magnetic field for this conductor. So current is going in this direction, so first I'll draw the magnetic field line, which is a circle around the conductor. One side is solid, the back part is dotted. So I'll hold the pencil in the same direction of the current, so you'll see from top of the conductor the magnetic field lines are going in downward direction. So I'll just put one arrow out here. Now in this diagram you can see when something goes into the plane of the paper, then we have to denote it by cross, and when something comes out of the plane of the paper, we have to denote it by dot. So this means something is going away from you. That means when an arrow goes away from you, you see the cross part of the arrow, and out here something coming out of the plane of the paper means it is coming towards you. So that means you will see the pointed part of the arrow. So we can denote something coming out of the paper by dot and something going into the plane of the paper by cross. So now suppose this is the conductor and this is going into the plane of the screen. So now in this diagram, this is the conductor and this conductor is perpendicular to the screen. So you can see only this part of the conductor and current is coming towards you. Now we have to draw the magnetic field for this. As we already know, if something is coming out of the plane, then we have to put dot. I know the magnetic field lines are circles around the conductor, so I am drawing the circle around the conductor. So now I'll use the rule. So current is coming towards you, so I'll hold the conductor in this fashion. So you'll find the magnetic fields are going in anti-clockwise direction. So I'll put the arrows according to this arrow. So this is the magnetic field of a conductor which is bringing the current from the screen towards you. Now in second case, the current is going towards the screen like this. So I'll draw the magnetic field line which is circle. Now I'll hold the conductor in this way with my right hand, pointing the thumb into the plane of the screen or plane of the paper. So you'll get the direction in opposite direction to this. So I'll just draw it like this. So these are the facts about the magnetic field of a straight conductor. So current carrying conductors creates magnetic field around it. So direction can be found out using right hand thumb rule, and the nature of magnetic field lines are concentric circles. You can see circle over circles, and the center of each circle is the conductor, and the strength of the magnetic field near the conductor is strong. As you can see out here, there are more magnetic field lines, so it is having strong magnetic field at near point, and when you go far away, the magnetic field lines are not that crowded. So that means the magnetic field is not strong at a point which is far away from the conductor. So we can increase the magnetic field of a straight conductor by increasing the current. So now let's summarize the video. So from Oersted experiment, we came to know a current carrying conductor produces magnetic field, and this effect is called magnetic effect of electric current, and the magnetic field line of a straight conductors are concentric circles, and the direction of the magnetic field can be found out using the right hand thumb rule. So I think it's the end of the video. It's time to give right hand thumb rule to my video. So these are the questions you can try. So in this question you have to find the direction of current. Out here magnetic field, direction of magnetic fields are given, and in this diagram you have to draw the magnetic field line of these conductors. So we have already done this kind of question in the video.